let's look at some graphs and see if we can come up with the polynomial equation for it. What do you say? Sketch the graph of the equation with a double root at -2, a single root at 5, and a triple root at 0. Assume the lead coefficient is negative. Write the equation of the function that describes the graph. So first thing I noticed was they had that triple root of 0. Remember, if they're doing a double root, that would be squared. Triple root in this case would be cubed. So if the root was 0, that would just be like an x on the outside. But this is a triple root, so it would be x to the third. That handles that. We have a double root at -2. So if it was just -2, that would show up as x plus 2. But this is a double root, which means it's going to be x plus 2 squared. We have a single root at 5. So x minus 5. The only other thing they said is assume the lead coefficient is negative. All right. Now let's figure out the degrees on this. Here would be 3 degrees. Well, you know what? We're going to have a root at 0, triple root. We're going to have a root at -2, like it said. And we're going to have a root at +5. 1, 2, 3, 4, 5. All right, so we're going to multiply this out and come up with the equation for it. Now, I'm going to do this square stuff first. There was a shortcut for when you have a binomial squared. If you forget it, you can always just do x plus 2 times x plus 2 and FOIL that out, and you would come up with the same answer. And this shortcut only saves you one step, so it's not that big of a deal if you forget it. But the shortcut was you square the first term, x times x is x squared. You multiply them together and then multiply by 2, because there would be 2 of the same things if you FOIL. So this would give us 2x times 2 would be 4x. And then you square the last term. 2 times 2 is 4. All right. I don't know why it's got the delay going on. A little nice delay effect. Okay. So, we can multiply the parentheses first, or we can distribute the negative x cubed to one of them first. I'll just go ahead and distribute the x cubed. Why not? So that would give us negative x to the 4th minus minus 4x. Oh, I forgot my squared on the first one. Sorry about that. Boop. Phew. So that'll change this. Oh my gosh, this is driving me bananas. My goodness. All right. Negative x to the 5th minus 4x to the 4th. And then negative x cubed times 4 would be negative 4x cubed. So we need to multiply all of that by this other binomial, the x minus 5. So again, when you're multiplying these, you just have to make sure you're multiplying everything in one set of parentheses by everything in the other set. So we'll multiply them all by x first, which just puts an extra x on each of them. It's going to bump up the exponents by 1. So we'll have negative x to the 6th minus 4x to the 5th minus 4x to the 4th. 10 minutes from now, that'll probably show up on the board. And then we're going to have to multiply all those terms by negative 5, and then we'll combine our like terms. Wow. All right. Negative 5 times negative x to the 5th. Negative times negative is positive, so that would give us positive 5x to the 5th. Negative 5 times negative 4x to the 4th would be positive 20x to the 4th. And negative 5 times negative 4x to the third would be positive 20x to the third. We'll combine our like terms here. We got negative x to the sixth, 5x to the fifth minus 4x to the fifth would be 1x to the fifth, so plus x to the fifth. 20x to the fourth minus 4x to the fourth would be 16x to the fourth. And then we also have the plus 20x to the third. So as far as the graph, it's an even function, which means they start and end in the same place, and it's a negative lead coefficient, which means they're both going to start and end at the bottom, heading towards negative infinity. So we're going to come up through this negative 2, but negative 2 had a multiplicity of 2. So remember, if it has an even multiplicity, it hits that point and then it turns back around. Great. So remember that for even multiplicity, hits it, turns around. The odd multiplicity, like this x to the third at 0, there's going to be a little bend in the graph at that intersection. So when we hit 0, there's going to be like, ugh. Well, I mean, that looks terrible. Let me see. It's so bad. I never do this. It's so bad, I'm going to undo my line and redo it. Let's try that yet again. Oh my goodness. This is going to be a 48-minute video for 10 minutes of notes. Coming up, hit negative 2, coming back up. We're going to hit that 0, but bend through it, and we got to come back down through that last point. That was a doozy. That was tough, man. Now the rest of them, they're just going to give us a graph. We have to figure out what's going on with the multiplicity there, and then we're going to multiply it out to come out with the polynomial. I just have to adjust something on my screen here. Oh gosh, now there we go. All right, now I can see again. So here they give us the graph. Now if you look, the start and end behavior, it starts heading down, ends heading up, which means it's an odd polynomial. It's an odd degree, and if it starts at the bottom and ends towards positive infinity, that means the lead coefficient is positive. So let's look at our zeros here. It crosses at negative 3, negative 1, and 2. And it just crosses right through them. There are no bends, there are no hits and turns around, so they're all going to have a multiplicity of 1. So the lead coefficient is positive, so it'll be positive 1 out in front. But we'll have, for the negative 3 over there, that would show up as x plus 3. For negative 1, that would show up as x plus 1. And then for positive 2, that would be x minus 2. So here's the equation in factored form. But we have to multiply this out. So pick any two of them and FOIL them. I'm just going to pick the first two. First, x times x is x squared. X times 1 is x. 3 times x is 3x. And 3 times 1 is 3. So if we combine those x's in the middle, that would give us 4x. So the first two binomials after we multiply would give us x squared plus 4x plus 3. We still have to multiply this by the other x minus 2. So we'll get them all with the x first. X times x squared is x cubed. X times 4x is 4x squared. And x times 3 is 3x. Now we'll get them with that negative 2. Negative 2, x squared. Put it under your other x squareds. Negative 2 times 4x is negative 8x. I'll put that under my other x. And negative 2 times 3 is negative 6. We'll combine our like terms, and then we're done. X cubed. 4x squared minus 2x squared is 2x squared. 3x minus 8x is negative 5x. And we'll bring down our negative 6. So this would be our final polynomial equation. Whew! Alright, we're feeling a little easier now. Oh gosh! Again, this one starts in one direction, ends in a different direction, which means it's an odd function. Also, if it starts at the bottom, ends at the top, that means the lead coefficient is positive. So let's write it with our zeros here. So it crosses at negative 3, so that would show up as positive 3, x plus 3. It crosses at 2 and 4, so that would be x minus 2 and x minus 4. Now if you look, they also marked the point 0, 24, which would be the y-intercept. And the y-intercept with these polynomials is always just the constant term at the end. So we don't need to use that right now, but it will show up in our equation later if we've done it correctly. Woo! I hope you do. So let's FOIL out these first two parentheses. X times x, x squared. X times negative 2, negative 2x. 3 times x, 3x. And 3 times negative 2 is negative 6. So combining the x's, that would give us positive 1x. So we have x squared plus x minus 6. We still have to multiply this by the other x minus 4. So we'll multiply the x first. It's just bumping an x on each one. So that would be x to the third, x squared, negative 6x. And then we'll get them all with the negative 4. Negative 4 times x squared, negative 4x squared. Negative 4 times x is negative 4x. And negative 4 times negative 6 is positive 24. Okay. So, combine our like terms. We've got x cubed. X squared minus 4x squared. 1 minus 4 is negative 3. X squared. Negative 6x minus 4x is negative 10x. Then we have our plus 24. That is a good sign that we got it right. If it shows up with a plus 24 at the end and the y-intercept was 24. We are so smart. Great job. It sounded like I was complimenting myself since I was the only one working on it. All right, here we go. Again, it starts and ends in different directions, which means it's an odd function. It starts at negative infinity, it goes towards positive infinity, so that means our lead coefficient is positive. Let's look at our zeros. It hits at 2, but you notice that it hits it and turns around, which means it has an even multiplicity. Now we just go with multiplicity of 2 if we're not sure, because maybe it has a multiplicity of 4 or 22. We don't know, but you go with just the smallest one there. So we'll have x minus 2 squared. It also just crosses right through at 4, so that would say x minus 4. So here it is in factored form. We just got to multiply it out now. X minus 2 squared. Square the first term, multiply them together, and multiply by 2. That would give us negative 2x times 2 is negative 4x. Square that last term, negative 2 squared is positive 4. We still got to multiply this by the x minus 4. We'll get them all with the x. That'll give us x cubed minus 4x squared plus 4x. Now we'll get them all with that negative 4. That'll give us negative 4x squared. Positive 16x. And minus 16. X cubed. Negative 4x minus 4x would be negative 8x. I meant squared. So negative 8x squared. 4x plus 16x is 20x. You got your minus 16. Now, if I said, what is the y-intercept of this graph? You would tell me the y-intercept is negative 16. That doesn't even show up on the graph, but if we zoomed out on that graph, it would hit the y-axis at negative 16. Cool. We got one more. Whoa! Now, if you look at this, it's starting at positive infinity. It has a lot of curves and stuff, and it ends at positive infinity. I see that it has a y-intercept at 16, so hopefully 16 shows up somewhere in our final answer. But I see that all the zeros, it's just crossing through, so everything's going to have a multiplicity of 1. So it crosses at -4, that would say x plus 4. It crosses at -1, that would say x plus 1. It crosses at positive 1, that would say x minus 1. And it crosses at positive 4, so that would say x minus 4. Now you could totally foil two of them, and then bring them together. But taking the problem as a whole, I like looking for shortcuts. If you notice, we have an x plus 4 and an x minus 4. That could create a difference of squares. We have an x plus 1 and an x minus 1. That could also create a difference of squares. So I'm just going to kind of rearrange my parentheses. X plus 4 times x minus 4, x plus 1 times x minus 1. Because the difference of squares is nice and easy. Middle terms end up canceling out. So you square the first term, you put a minus, and you square the second term. If we square x, that would be x squared. Put a minus, square the last term. 4 squared is 16. If we do the same thing over here, another difference of squares, square the first term, x squared, put a minus, square the last term. 1 squared is 1. And it would, if you would FOIL these out originally, it's still going to work out to the same answer, but this is a little bit less work. Now these two we're going to have to FOIL. X squared times x squared would be x to the 4th. X squared times -1 would be -1x squared. Negative 16 times x squared is negative 16x squared. I'm going to put it under my other x squareds. And negative 16 times -1 is positive 16. So if we combine our like terms there in the middle, we'll have x to the 4th minus 17x squared plus 16. Oh, its y-intercept is 16. Holy smokes, great. Also, like, keep in mind all the stuff we learned. It has a positive lead coefficient, great. It starts and ends up top. It has an even degree, 4. These are all things that we've been practicing over the last week, but things that you can give yourself a quick double check and make sure your final answer has those traits in it. All right, now these, we only have to write it in factored form. We don't have to multiply it out at the end. Now if you look at the graph here, it starts at the bottom, kind of cruises up through here, it comes back down, and then it cuts off, but really if we zoomed out, it would end up attaching over here, and it ends up going in towards positive infinity. So it starts low, it ends high, which means it's an odd degree, and it's a positive lead coefficient. Those are good things to keep in mind. So, state the degree, we don't know yet necessarily. Lead coefficient is positive or negative, it's positive for sure. And then write it in factored form. So let's look for our zeros here. I see it's got a 0 at -3, but you'll notice it doesn't just cross through there. There's that bend, which means it has an odd multiplicity. So we're going to write that the lowest odd number, odd exponent, would be 3, right? Because we don't include 1. If it was with a multiplicity of 1, it would just cross right through that point. But this one has that bend, so we're going to say it has a multiplicity of 3. So we would write that as x plus 3 to the 3rd power. That handles that 0. Comes up here, then it cruises down here, and it crosses at +1. So that, and it just crosses through. So that means it has a multiplicity of 1. So we'll say x minus 1. And then it just crosses through at +5. So that would show up as x minus 5. So here's the equation in factored form. Now if it says what degree is it, if you look, this one has a multiplicity of 3. This one has a multiplicity of 1 because it's to the 1st power. And this one has a multiplicity of 1 because it's to the 1st power. So that means our final polynomial, 3 plus 1 plus 1, it would be the 5th degree. Now, you could certainly multiply this out. You just don't need to on this problem. So, I believe in your abilities. I know that you are able to do it, but let's save yourself a little bit of time. We're going to do the same thing on number 6 here. Now, again, 6 is kind of zoomed in a little bit. I'm going to make it a little smaller. Now, if you look, it starts up here. It comes down, goes back up, goes back down. It would curve around like that, and it would curve around like this, and it would end up. So, it starts at the top, and it ends at the top, which means it's an even degree, and that means it's a positive lead coefficient. We don't know the degree yet. We're going to have to write it in factored form and figure out how many zeros we got. So if we're looking for the zeros, I see it hits at -7 and then turns around, which means it has an even multiplicity. So we're going to use squared. So that would show up as x plus 7 squared. I see it does the same thing at -4. Hits it, turns around. So that would show up as x plus 4 squared. It crosses right through 0, and if it crosses, it's to the 1st degree. Now you could say x minus 0, but x minus 0 is just x. So we're just going to put that x on the outside. And then it crosses through at +2. There's no bend in there, so it would be a multiplicity of 1. So we have x minus 2. So here it is in factored form. Again, it can be multiplied out. No need though. We just need to figure out the degree of the final polynomial. So here would be the 1 degree. This one's squared, so there's 2 more. This one is also squared, so there's 2 more. And then this is to the 1st power, so there's 1. So 1 plus 2 is 3, plus 2 is 5, plus 1 is 6. So it would be a 6th degree polynomial. A lot of info jammed in there. I think that's the last slide. That's it. So let's practice. We got a joke worksheet for this one. Super exciting. I'm so excited for you.